With as much as 30% of all species potentially at risk of extinction, there is an urgent need for action, but there simply aren't the resources to protect them all. This presents a Noah's Ark problem of selecting species for conservation. This week, at the Royal Society meeting in London, scientists discussed how to decide upon priorities for conservation. By organising species into an evolutionary tree of life, scientists can measure the relatedness of different species, just like an ancestral family tree. Dr. Jonathan Davies from McGill University explains how these trees can be used to prioritise conservation.
Measuring individual traits, how big, how wide, how heavy species are, is possible just for a few species, because of course there are somewhere between 10 and 100 million species on Earth. So we can't do that for all species. But what we can do is we can measure the branch lengths on that tree of life that connect them. And the assumption is that the longer those branch lengths are, the more millions of years of evolutionary history that separate species, and therefore the longer they've had to accumulate features, novel features, which are adaptations to the environment.
What elements of this tree would you prioritise to keep and preserve?
Well, we might just want to maintain the greatest amount of branch length that maximise the millions of years that connect species. Because as we lose species, we lose those millions of years of branch lengths. Another measure is just the number of branches. Every species represents a unique branch. So we might want to not worry so much about how long those branches are, but just count how many branches we're at risk of losing through extinctions.
Scientists are now using the length of these branches to score the evolutionary distinctiveness of a species and combining it with its level of global endangerment. This method is referred to as EDGE and is currently one of the biggest efforts to select species as priorities for conservation. But what are the benefits of conserving this tree of life?
Well, for the world it means many things, but often we have a very sort of anthropocentric view. What can biodiversity do for us? And biodiversity provides services. We often call these ecosystem services. They're goods that natural systems provide humanity. And so there are three sorts of services that biodiversity can provide. There are regulating services. They regulate climate, for example, and flood control. There are provisioning services. These are the timber or food that we harvest from natural environments. And there's also cultural or ethical goods that ecosystems provide us. And so species, we don't know how many species we need to provide those services or which ones in particular, but we know biodiversity provides those services for us, and we want to maximise the chances of biodiversity in the future continuing to provide those services.
2014 marks 50 years of the International Union for Conservation of Nature, or IUCN, Red List, which allocates every species an extinction risk category, from that of least concern to extinct. However, the survival of a species is often dependent on their specific habitat. Now, the IUCN are introducing a similar red list for ecosystems. John Paul Rodriguez, Deputy Chair of the IUCN Species Survival Commission, describes plans for the project.
We're trying to build a system that classifies the risk of loss of ecosystems and gives them a category reflecting that loss. So hopefully in about 10 years or so, we expect to have coverage of the world's ecosystems, and the map color-coded how threatened they are. So the most threatened ones will appear in red because it's a red list, and the less threatened ones in other colors.
This meeting showcased the scientific research into the best course of action for conservation efforts. However, the next stage is to get these findings taken on board by policymakers. Dr. Laura Pollack from the University of Melbourne describes current progress in these goals.
I think it's one of those things that we value from sort of a global perspective in terms of prioritizing which species that we care about, but a lot less is being done, especially at a regional level, in terms of on-the-ground practical conservation. And so what we're trying to do is form a method for actually integrating these processes that we think are important into conservation planning. And so we're starting with just evaluating which policies are currently being implemented and how that does in terms of preserving the evolutionary history of species.
Can we see any benefits from these things being implemented?
I think, again, from a global perspective, we can see some conservation outcomes and some benefits from programs like EDGE. In terms of the local conservation and in terms of integrating this into local policy and management, I think it's still very early days.